We'll start on 6.4 here, multiplying and divide integers. So a little shift in gears now, okay, because we just did addition in 6.2 and 6.3 was subtraction of integers. Remember, integers just means positives or negative whole values. But the rules are just a little bit different for multiplying and dividing integers, which we'll see. Now, just like we did with both addition and subtraction when we're operating with negatives, is we just want to determine if the answer is positive or negative first. That's the first thing we want to do. If we can do that and we feel comfortable multiplying and dividing, which we should by now, because we've had a lot of practice with it, not only in the classwork, but also in the homework and also quizzes, then this becomes pretty easy because we can determine pretty quickly if an answer is positive or negative, and then the operation should come pretty natural at this point. So this is kind of our basic understanding with negatives, and this is only dealing with two values at a time. If you're multiplying or dividing and the signs are the same, positive or positive, that's one we have the most experience with so far. Remember those answers were positive? It's the same thing if the two values were negative and negative. Then your answer is positive. So this is said in a few different ways. Some people say if you got two negatives, it gives you a positive. Some people say a negative and a negative is a positive. Okay, that's true. But remember, it's only for multiplication and division. It's not necessarily true for addition and subtraction because remember, we were using keep, change, change with that subtraction stuff. So that's when the signs are the same. Positive, positive, negative, negative, your answer is positive. But what about when the signs are opposite? If they're opposite, then your answer is a negative. Negative multiplied or divided by a positive is a negative, or if you switch it, positive multiplied or divided by a negative is a negative answer. Okay, so as long as we have these down, we can figure out pretty quick, at least, remember that's the first step, is to determine if your answer is positive or negative. Once you figure that out, then we're just going to operate directly. And we're looking at the operations of multiplication and division today, or at least in this section. So here's 5 different sets. Now we're not solving these. We're not actually going to do the multiplication because we just want the practice of determining if the answer is positive or negative. Now, could we do the multiplication? We should be able to. We should feel comfortable doing that, especially with these bigger numbers like this. We should be able to stack them and multiply. But that's not what we're concerned with right now. Another thing about this, we see all 5 of these are multiplication, okay? Remember, it's multiplication or division. We'll do 5 more with division next. But remember, multiplication is the only operation that does not have to be shown in certain scenarios like this one, right? So while we don't see the operation, we should know that it is multiplication because it's not shown. Same with this one, okay? And yeah, we do need the parentheses, especially on this one, because without the parentheses, this would be 4,321 minus 18. They're crucial, and they do essentially change the operation as well, okay? So determining if the answers are positive or negative, just based on what we saw. Remember, if the signs match, then the answer is positive. If the signs don't match, then the answer is negative. So on this one, here's a negative and a negative. Well, if we see that they're the same signs, negative and negative, then the answer is a positive. All right, and this will be true for positives and positives, which we will see as well. On this next one, we have a negative 875 and also a positive 436. They are different signs. And when they're different signs or opposites, the answer is a negative. Or this next one, once again, we got a negative and a negative. 2 negatives makes the answer a positive. At least when we're multiplying anyways. So there we go. That answer is a positive. And then this next one, we got a positive 4,321 and a negative 18. They are opposite signs, which means this answer would be a negative. And then this last one, again, we've seen plenty of examples like this where we take a positive and multiply it by a positive. If that does happen, then we should know already that the answer is a positive. Done. Okay. Now, and again, I can't stress this enough, is if you can do that, if you can just determine if an answer is positive or negative, however quick it is, But once you can do this with some proficiency, then you should be able to do the multiplication already by now. We expect you to have that skill down at this point. So there we go. We determined if those were positive or negative, and then we would operate on these values after that. But we'll do the same thing with division on these ones. Again, it goes the same way with division as it does with multiplication. If you can just determine if the answer is positive or negative, then you're looking at some division after that. Yeah, you may have to use some long division, but again, that shouldn't be a problem for us at this point. So we just want to determine if the answer is positive or negative. So on this first one, the 71 is positive, the 3 is negative. Since they're opposite signs, the answer is a negative. Or on this next example, 456 is negative, 9,631 is negative. These have the same sign, and when the signs are the same, the answer is a positive. Remember, this is only with division and multiplication as well. Now, this next problem here, it's showing a fraction line. But remember, fraction lines indicate division. So yeah, we're still looking at division here. And we just need to figure out how many negatives there are, right? 1, 2 negatives, 2. We'll get more into that later. But remember, a negative and a negative, no matter how you look at it, just like we did with horizontal division or just old-fashioned division, yeah, it's still going to make the answer a positive. Now, this next one, this is where we get some confusion, especially with fractions and we see negatives. If you ever see a negative like this, there's only one of them, okay? Because some students would say, well, is the 27 and the 9 negative? No, not both. Not both are negative. In fact, what we would like you to do now is to think of this negative as only applying to the numerator, okay? Generally speaking, we don't apply it to the denominator, although you can, technically speaking. But if you can just get in the habit right now of applying that to the numerator, you're going to make your life a lot easier. And what do we get on this one? Well, the 27 is negative, and the 9 here is positive. They are opposite signs, which means that the answer to this one would be a negative. Whoops. There we go. This one's a negative. And so the next one as well kind of matches just horizontally. We got a negative 84 and a positive 12. Negative and a positive, they are opposites, which would make the answer a negative. And now that we know that the answers are either positive or negative, just like we would with multiplication, then we would proceed with the operation. All right, so in determining if answers are positive or negative, especially when we're just dealing with two terms, we're gonna use that process of just saying, okay, negative and a negative is positive, 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 positive. But when they are opposite signs, then we're going to make the answer a negative. So that's our first step. Just like we would with addition or subtraction, we want to determine if the answer is positive or negative, and then we will perform the operation, which in this section we're just looking at multiplication or division. Remember, when you operate here and you determine the sign of the answer, just remember that you'll have your sign, but when you're operating with those numbers, now you get to ignore the signs of all of the numbers, okay? And that should help us to perform. Usually it's multiplication with many numbers, but even if it's division, it works. Now, of course, we see a curveball in this first one. 0, remember, is neither positive nor negative. But this may help us to think back to what multiplication is. And on this one, would say, well, you got -1 groups of nothing. Remember, 0 is pretty much nothing. Well, it doesn't matter how many groups of nothing you have. Even if it's negative, well, you're still going to end up with nothing on that case. So that's 0 right there. Or if we remember back from the multiplication section, just even when we're dealing with positives, anything multiplied by 0 is just 0. And the sooner you make this an instinct where you see, oh, I see multiplied by 0, the answer is 0, I think you'll be doing yourself a big favor on that. But here we go. So we are actually performing the operation. But before we do the operation, remember, we're just going to figure out if the answer is positive or negative. And what do we see on this one? Well, I see 2 negatives on this one. A negative and a negative makes the answer a positive. So I'm putting the positive sign there. Again, it's not required that you put that in the answers for the assignment. In fact, if you did, I think it'd mark it incorrect. But now that we know the answer is positive, all we're going to do is treat both numbers as though they are positive. And we're going to perform the operation, multiplication. 8 times 4, that's one of those old arithmetic memorizations from the multiplication tables. We would like you to know 8 times 4 is 32. You can stack it if you need to, but you end up with the same answer, 32. And yeah, I don't really need that positive sign. It's just 32. You can say positive 32 if you'd like, though. All right, so 10 times 1 is 10. And yeah, since the signs are opposites, we have a negative answer. But now that we did the multiplication there as 10, we'll just apply the number to the sign, and that then makes it negative 10. So here we go. This is more multiplication here. And what do we got? I got positive 7 and multiplied by negative 7, right? So 7 times negative 7. Well, we want to determine the sign of the answer first, and that's positive and a negative. They are opposite signs, which makes our answer a negative. And then from there, again, we're just going to ignore the signs. 7 times 7, which we should know by now is 49. But applying that with the negative makes that negative 49 as our final answer. And again, be careful with that because sometimes we get used to showing that sign up there, but then we forget to apply the number to it. It doesn't happen too often, but it does happen from time to time. I make that same mistake too. All right, negative 92 times negative 14. And yes, we do have a negative and a negative. That's going to affect our answer. Remember, we want to just determine if the answer is positive or negative, and 2 negatives makes a positive answer. So showing the positive sign just so I remember that the answer is positive. But from there, it's just straight multiplication. 92 times 14. I'm going to need to stack these to multiply them. Let's see, we'll get 2 times 4 is 8. 4 times 9 is 36. Then we're in the tens place value, so 0 on the ones. 1 times 2 is 2, and 1 times 9 is 9. I almost said 18. Need to add those together. That'll be our final product. 8 plus 0 is 8. 6 plus 2 is 8. 3 plus 9 is 12. So 1,288. Remember, it's positive, just like we saw up there. 1,288. I don't really need the positive sign, but we can box this in. So here's our first division problem. We got 42 divided by negative 6. And so this isn't, I mean, you could use even a fact family to figure this one out, especially if you have your multiplication tables memorized. But let's just first figure out if the answer is positive or negative. That's the first thing we should do. And what do we got? We got a positive 42. It's positive. And then the negative 6. Well, they're opposite signs. One's positive, one's negative. So we know the answer here is going to be a negative as well. And then remember, we get to operate as though we don't have any signs, right? It's really 42 divided by 6. If you were to use a fact family on this one, you could rearrange it to be 42. I mean, that's pretty direct, but it'd be equal to 6 times something. I don't know if that helps. But in any case, yeah, you can switch those. I guess it's not really going to make a difference. No matter what you get on this one, it should be 7. 42 divided by 6 is 7. We should have that memorized, no matter if you're using the fact family or not. And so negative 7 is our final answer. Bam. Or this one, negative 56 divided by positive 8. And so with the negative 56 and the positive 8, well, these are opposite signs, which means that the answer is a negative. Well, then we just do straight cross 56 divided by 8. And again, if you need to set this up with some long division, that's up to you. Just do it whichever way you feel is most accurate for you right now. 8 will go into 56 7 times. 7 times 8 is, 56. So that gives us a remainder of 0, just like we would want. And then this 7 down here. We'll just apply it to the negative that we saw before. We know that's the sign of the answer. So negative 7 is our final answer. More like this one. Here we got negative 49 and negative 7. Remember that fraction line represents division. And since we got two negatives on this one, the answer is going to be a positive. Okay, so I got my positive sign. I won't apply it to the answer, but I want to see it up there so I know my answer is a positive. We did that work. Let's go and do the division. 49 divided by 7. Or if you want the long division, 49 divided by 7. It's up to you. In either case, you're going to end up, oh, there's another 7 problem. It's unusual to see answers like this the same, but I don't really need that positive symbol. And the final answer is just 7. We're here. Still division, even though it's that fraction line. Remember, that's not a big problem. And, well, 10 is positive. The 1's negative. And those are opposite signs, which makes our answer a negative. And from there, it's just 10 divided by 1. Remember, anything divided by 1 is the identity property for division, so it's really just 10 right there. Remember, we can make that a phantom divide by 1. Remember, that divide by 1 is still there. You just can't see it. So it's hiding in the shadows, always watching, which makes those, that's what makes those phantom values so creepy. But negative 10 is our final answer on this one. All right, here we go. We see some bigger numbers now, so we'll definitely use some long division on this one. And we can see, just in the beginning, we're dividing by 3. I know we haven't figured out the sign of the answer yet. We'll get there, but remember to determine if this is actually divisible by 3. 5 plus 6 is 11, plus 3 is, plus 12. 2 is 13, plus this other 2 is 15. 15 is divisible by 3, so 3 will go into 5,622 evenly. We should not expect a remainder on this one. But we see that both of these values are negative. Negative and a negative, even with division, makes a positive answer. So there's my positive sign for the answer. All we need now to do is to take the two values and divide them, but we're not worried about the signs anymore because we know that the answer, we already know the sign of the answer, so we're not worried about the signs of these values. It means we can directly divide them. 3 will go into 5 once. 1 times 3 is 3. 5 minus 3 is 2. Drop it to 6. Makes that 26. 3 will go into 26 8 times. 8 times 3 is 24. Subtract, and we got 2 there. Drop another 2 to make it 22. 3 goes into 22 7 times. 7 times 3 is 21. When I subtract that, I get 1. Drop this other 2 to make that 12. 3 goes into 12 4 times. So we see it goes into it evenly. 4 times 3 is 12. And so our remainder here is 0. So our quotient there, 1,874, as part of the answer makes it positive. And again, I don't really need the sign for the answer there, but we know that it's 1,874. So here's another one. And now we see more multiplication on this one. There's a lot of multiplication, by the way. And I'm going to show you kind of a shortcut on this one. Whether you apply the shortcut or not is really up to you. But I'm going to operate with these 2 at a time from left to right. Okay, this is all multiplication. And I'm kind of doing this to drive home a point, which we'll see on the next slide. And then we'll try this problem again with that second method, okay? So we're going to solve this. Let's go ahead and give ourselves a little bit of extra space here. And I'm going to start first with, just on the left here, with -1 times -2. Now, to do this a little bit quicker, although, for some people it may take this a little bit more time because we got to think about each pair at a time. But that's a negative and a negative, which is going to make that a positive answer. 1 times 2 is 2. Then I would take that 2. You'll see work like this, especially with lots of values like this, with this little v thing right here. And so I'm kind of using this in so that you can kind of prepare your mind to see it in the future. But that's 2 times -1. The blue 2 times black -1. That's a positive and a negative, so I know my answer is negative. 2 times 1 is 2. So there's that -2. Then I'd have to multiply that by the next -1. The -2 in red times the next black -1. A negative and a negative makes that answer a positive. 2 times 1 is 2. And so we kind of see a little bit of a pattern now. But this positive 2 in purple times the black -1 next makes that -2. And then this green -2 times the next one. It's just a positive one. So that's the identity property. I'm going to get a positive 2 out of that. So we're using up a lot of the values, we're just working from left to right. We're getting there. So I got to multiply the orange -2 by the next black -1. Negative and a negative makes that a positive. 2 times 1 is 2. Then I'll take this blue 2 and multiply it by the next black -1. So that's 2 times -1, which is, that's a positive and a negative, which makes that answer a negative. 2 times 1 is 2. And then I got this purple -2 multiplied by the next black -1. A negative and a negative makes a positive. 2 times 1 is 2. Bam. Like I'm running out of space. Then I got this green 2 times now -10. A positive times a negative makes the answer negative. 2 times 10 is now 20. And then I got to multiply that orange -20 by the next one. It's a negative times a positive, which makes the answer negative. 20 times 1 is 20. Continuing though, we got this -20 in blue times the next -1. It's a negative and a negative, which makes the answer positive. 20 times 1 is 20. So that red 20 times the next -1 makes that positive and a negative. That's a negative answer. 20 times 1 is 20. Now you kind of see I wouldn't say the futility in this, but at least kind of the monotonous of it. So -20 times 1, maybe monotonous is not the right word, but I hope you understand what I'm saying. -20 times +1, a negative times positive is negative. 20 times 1 is 20. So that's a -20. That's our final answer. Now, remember this, okay? Because that may have felt kind of painful, but there is little shortcuts that we can take, especially if we can understand some of our old multiplication rules. But we're going to introduce a new one specifically with multiplication, but again, it would work with division as well. So here is what we're looking at here is it says how many negatives are there? So it's a couple questions that we got to ask ourselves, okay? When we look at long problems like that one, how many negatives are there? Now, well, we would not look at a number like this one, -4. This is not 4 negatives. This is not 4 negatives. It's just one negative. Okay, so it would say that's one negative. If I looked at more multiplication, like a -3 here, now it's 2 negatives. Okay, there's one negative and one negative. 1, 2 negatives. So that's how many negatives there are. When it says how many negatives are we're just counting the negative signs, not that this is 3 negatives. This is not 4 negatives. That's not what this is asking. Okay. So keep that in mind. Is that we're trying to figure out how many negatives there are. Now, if there are an even number of negatives or an odd number of negatives, will determine the sign of the answer. So if there are an odd number of negatives, the answer is a negative. If there are an even number of negatives, the answer is a positive. So we'll want to remember that, like this one right here. Okay. So this one shows 1, 2 negatives. 2 is even, so we would know the answer is a positive, and then we could multiply. Which takes us back to the original rules that we saw, right? If there's an odd number of negatives, such as negative times a positive, then we ended up with a negative answer. Or if you took a positive multiplied by a negative, that answer also was negative as well. Okay, that's because there's an odd number of negatives in these problems, right? 1 negative, 1 is odd, the answer is negative. 1 negative, 1 is odd, the answer is negative. Or, like we saw before, and I guess it works with zeros and evens, but like we saw, a positive times a positive, of course we know that answer is positive. But if you saw a negative times a negative, the answer is a positive as well. Why? Because there's an even number of negatives. 1, 2 negatives being multiplied makes the answer a positive. So we're going to apply that to the problem we just saw on that last slide. All right, and you'll kind of see the difference in time. It's not necessarily more convenient unless you feel like this is the more appropriate approach for you. Right? Like, do you prefer this? If you don't, then don't worry about it, okay? But how many negatives do we see on this one? I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's 11 negatives. And remember, this is just to determine if the answer is positive or negative. That's it. 11 negatives. 11 is odd. Okay. Since 11 is odd, I would know that the answer is negative. Okay, so I'm going to put that in right now. Since there's an odd number of negatives, I know my answer is a negative. So I put my negative sign right there. Okay, now I will proceed to do the multiplication, but I'm not worried about the signs anymore. I don't care about the signs in the multiplication problem. In fact, going back to our multiplication section, anything times 1 is itself, so I don't even need to multiply by these 1's right here. I'm just going to cross these out. And what are we left with? All I'm left with is 2 times 10. Well, I already know that 2 times 10 is 20. So that is the product of all these values. And yeah, you could say, well, 20 times 1, lots of 1's, no matter how many 1's you get, is itself. It's the identity property. So we end up with negative 20, which is the same answer we saw on that last one, right? Even though we did it in a different way. And so that's the main point is, even though, for me, I feel like this one's more convenient for me because I prefer it. But if you feel like that last method is more preferable for you, feel free to do it. All right. So same thing on this one. I'm just determining if the answer is positive or negative. And yeah, there's only 3 terms. So technically, is either method a shortcut? I don't think so, but I'm still going to use that second method. Let's count how many negatives there are. 1, 2. Okay, 2 negatives. 2 is even. So I know that my answer is a positive. Okay. And from here, I don't worry about the signs anymore. It's just 2 times 5 times 2. And I know 2 times 5 is 10. And then 10 times 2 is 20. So that's a positive 20. And yeah, we don't really need the positive symbol there. It's just 20. It's good. That is our final answer. And then even with 4 terms, yeah, it still doesn't matter. We're still going to count how many negatives. We got to determine if this the sign of the answer. And how many negatives is this? 1, 2, 3. Just like the last problem. 3 negatives. 3 is odd, so I know the answer is a negative. After that, it's just multiplication of the numbers, but we're not worried about signs anymore. So 2 times 4 is 8 first. 8 times 3 there is 24. And then 24 times 5. I'll have to stack that. 24 times 5. 4 times 5 is 20. Carry the 2. 5 times 2 is 10, but add the 2 makes that 120. So there's a 120 from the multiplication. Applying the sign makes it negative 120.